Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In today's episode, we're focusing on secure design and secure coding guidelines, two of the most critical pillars in modern software development. Whether you're building an internal tool or a large-scale application used by millions, embedding security into the design and coding phases helps prevent costly vulnerabilities, maintain user trust, and meet regulatory requirements. Security that's added after the fact is often inconsistent, expensive, and incomplete. But when design and coding are done with security in mind from the start, you're building resilience, reliability, and confidence directly into the core of your software. As a certified information systems security professional, you'll be expected to understand both principles and best practices for developing software that's secure by design. Let's start with a foundational understanding of secure software design. Secure design is the practice of applying security principles during the architecture and planning stages of a software project. Rather than waiting for the development or testing phases, secure design assumes that every software component must be built with protection in mind, right from the beginning. Effective design anticipates potential threats, defines required security controls, and ensures that defensive mechanisms are embedded within system components. It means applying principles like defense in depth, so that multiple security layers protect against a single point of failure. It also means enforcing the principle of least privilege, where every user and system component gets only the access it absolutely needs, and no more. Secure defaults are another key element. For example, systems should be configured out of the box to deny access rather than allow it, and password requirements should favor complexity and expiration instead of convenience. The idea is to make the secure path the easiest one to follow. Fail-safe mechanisms are also important. When something goes wrong, such as a failed authentication attempt, missing configuration, or system error, the system should fail in a secure state rather than leaving resources exposed. When security is built into the design, vulnerabilities are reduced before a single line of code is written. It also helps align software architecture with compliance requirements and organizational risk management goals. Understanding these principles gives you the tools to shape software that is inherently more secure, more resilient, and more trustworthy. Now let's turn to the importance of secure coding practices. While design defines the blueprint, coding puts that plan into action. Secure coding is about writing software in a way that proactively prevents vulnerabilities, regardless of programming language or development model. Every year, organizations lose millions of dollars due to software vulnerabilities like injection attacks, broken access controls, and improper input validation. Many of these flaws stem not from sophisticated threats, but from avoidable mistakes in coding. Secure coding helps prevent these issues by applying best practices from the start. Secure coding reduces the risk of buffer overflows, cross-site scripting, improper error handling, and insecure data storage. It creates code that behaves reliably, even in the face of malicious inputs or system failure. Secure coding also supports regulatory compliance. Frameworks such as the Payment Card Industry Data Security Standard, the Health Insurance Portability and Accountability Act, and ISO 27001 require that software development follow defined, secure practices. By following clear coding standards and best practices, developers improve both the security and quality of software. Bugs are fewer, systems are more resilient, maintenance becomes easier, and the cost of fixing vulnerabilities is dramatically reduced when they're caught early in the development cycle. Let's now walk through some of the most important secure coding guidelines every development team should follow. First, input validation. Never trust user input. Always validate, sanitize, and enforce constraints on all inputs before processing them. This helps prevent injection attacks, such as SQL injection or command injection, where untrusted input is interpreted as code. Second, output encoding. When displaying user-generated content in a browser, always encode the output to prevent cross-site scripting, or XSS. This ensures that even if a user enters malicious content, it's rendered as data, not executable script. Third, authentication and authorization. Always implement strong multi-factor authentication mechanisms. Enforce session management best practices, and make sure that users are only authorized to access resources appropriate to their roles. Never rely solely on client-side controls to enforce security. Fourth, error handling and logging. Be careful with error messages. Avoid exposing sensitive system information in logs or application errors. Logging should be comprehensive, but logs should be protected with access control and encryption to prevent misuse. Fifth, cryptography and secure storage. Use only strong, approved cryptographic algorithms. Avoid creating your own encryption schemes. Manage keys securely using centralized key management systems. And protect sensitive data at rest and in transit using robust encryption and integrity checking techniques. These guidelines serve as a strong foundation, but keep in mind that secure coding is not a one-time checklist. It's a discipline. Every team member, from junior developer to senior architect, must understand and apply these principles throughout the development process. For more information on CISSP certification and other valuable cybersecurity education resources, please visit cyberauthor.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let's now examine how to implement effective secure coding practices within your organization. Begin by clearly documenting secure coding standards. These documents should define acceptable practices, prohibited functions, secure design patterns, and how developers are expected to handle common scenarios. Next, integrate automated tools. Use static application security testing, also called SAST, to analyze code for known vulnerabilities without executing it. Use dynamic application security testing, also known as DAST, for testing running applications in simulated environments. Integrate these tools into the development workflow, not just at the end. Provide secure development training. Many developers are never formally trained in secure coding. A workshop, certification course, or peer review program can have a major impact on reducing security flaws. Make security training part of onboarding and continuous education for development teams. Conduct secure code reviews. These should be mandatory for all high-risk applications and include both automated scans and manual analysis. Peer reviews help catch issues that tools might miss and reinforce accountability and awareness. Establish security checkpoints. Throughout the SDLC, schedule mandatory reviews and assessments before moving to the next phase. This creates gates where teams can validate adherence to secure coding policies before software progresses toward deployment. Now let's review the security controls that support secure design and coding. Start with your development environment. Use integrated development environments, or IDEs, with secure coding plugins and code linting tools to help developers catch issues early. Secure your source code. Use version control systems with role-based access, change tracking, and code integrity verification. Repositories should be encrypted, regularly backed up, and protected from unauthorized access. Automate security testing within the build pipeline. As code is committed, run automatic scans for known vulnerabilities, deprecated functions, and insecure patterns. The faster issues are flagged, the cheaper and easier they are to fix. Apply access control across all development resources. Protect staging environments, test data, and production access with strong authentication, role enforcement, and monitoring. Conduct regular audits and penetration testing. Evaluate your development workflows, application architectures, and release practices. Validate whether secure coding practices are being followed, not just written down, and document everything. Maintain full records of training completion, code review results, incident response findings, and software composition analysis. These records support audits, compliance validation, and continuous improvement. Let's close with continuous improvement in secure software development. Threats evolve, coding languages change, frameworks are updated. Your secure design and coding strategies must grow alongside the ecosystem. Review your policies regularly. Use feedback from developers, security teams, testers, and business stakeholders to identify what's working and what needs improvement. Use incident data to improve your practices. If a vulnerability reaches production, ask how it slipped through. Was a check missing? Was a requirement unclear? Feed this analysis into your secure development strategy. Collaborate across functions. Security cannot succeed in a vacuum. Development, operations, legal, and compliance must be engaged to ensure that secure practices are well understood, properly enforced, and realistically scoped. Keep training ongoing. Offer certifications, gamified testing platforms, or monthly security labs to keep developers sharp. Promote security champions, developers who serve as go-to contacts for security questions within their teams. Thank you for tuning into the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Strengthen your understanding of secure design and secure coding guidelines, and we'll consistently support your journey towards CISSP certification success.